Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? What we have on the menu today is part 2 of this series of streams in which I am going to work on a project of mine called caxa. It is a Node.js project to package Node.js applications into a single binary that you can then distribute. If it's a command line application, your users will just download a binary and run it. Or in my main use case, if you have a web server that you want people to be able to self-host very easily, they can just download a single binary and run it, and it will be the whole server. That was the motivation for me to create caxa in the first place. And if you're interested in learning more about what caxa is and more or less how it works, you can watch the previous stream in which I went over all this. Today, we are going to look at the most pressing issue, and we're going to try to fix this thing that, or actually it's not an issue really. It's something that people want, and it's an improvement, and it's ARM support. So caxa depends on these stubs, these binaries that you attach your Node.js application to. And these stubs have been pre-compiled, and they are shipped along with caxa. And they're written in Go, and they have been compiled to Mac OS, Windows, and Linux in Intel architectures only. And what people need is an ARM version of the stub, and they want that for Linux. But since we are here, we are going to try to support as many platforms as we can. So we can go to nodejs.org and see what are all the platforms that are supported. And I'm having, as a side note here, I'm having this issue where NDI, the thing that connects my OBS instance that captures my computer screen and sends that to the computer that is actually streaming, there is this issue that it just takes a while to pick things up. For instance, now it changed to the screen that I changed to, but it seems like it takes 30 seconds to get what I'm doing. But the problem doesn't occur always. It only occurs sometimes. It occurred yesterday, and it's happening now. But it didn't occur in other instances in which I was streaming for more than 1 hour. I really have no idea why that could be. It may have to do with the network, but I have restarted the router and everything before I started streaming, so I have no idea what's going on there. In any case, we'll try to support as many of these platforms as we can. So Windows 32 and 64, Mac OS, Intel and ARM, and Linux, ARM, Linux, Intel, ARM 7, ARM 8. But also, since we are here, we'll also try to support Linux ARM 6, which is something that people requested. And those are the platforms that are officially supported by Node.js, so I think it makes sense to stay on this subset. And there are some news since yesterday. Some people watched the previous stream and commented out here on the issue, and they solved some of the things that I was talking about. One of the things we need to do is, as I said, to compile the binary, the stub, so that it works in all these different platforms. But the other half of the picture is that we have to detect when we are packaging the application. What architecture are you on? And then we package for that application. You need to select which stub to use when you're packaging. And I already know how to select a different operating system. I can just look at the process.platform variable that just, it's there in Node.js, no extra work necessary, but process.platform will give you the operating system. And then I select the stub based on that, because currently I only have one stub per operating system. But I didn't know how to select an architecture. So if I have Linux, then how do I select Linux ARM64, for instance? And there was another solution that was posted by someone else that was to use uname, which is a command line tool you can call that will give you some information about the operating system and the platform. And then we could parse that output. But it seems like there is also this other thing that is process dot arch. Okay, I don't seem to be having any output here, but it may be because I did not install all the tools I need to have autocomplete work. So we'll look into that, and we'll also look into this process.config.variables.arm version, because it seems like Node.js is already capable of saying what the platform is. So we don't need to necessarily call the command line, the uname command line. Now, the interesting thing about this is, why did the maintainers of PKG, the other solution for packaging Node.js applications that I mentioned in the previous stream, why would they resort to calling uname on the command line if this already exists in Node.js? I have no idea, because it doesn't even seem like it's a new thing. I mean, modifying process config has been deprecated in version 16, but it has been around since forever. I don't know why the other project decided to do that, but we'll try to use these variables. It seems like it's the best approach. So that's one part of the picture, detecting the architecture, and the other part is compiling the stubs. So in summary, two parts to the story: compiling the stubs to the different architectures, detecting in which architecture you are, selecting the right stub. That's the story. Now, the way I initially thought about how to compile to the different architectures was pretty simple. I'm already compiling to the different operating systems. I'm doing that with an npm script. It is this npm script right here, and I'm using the ability of Go to cross-compile, and that's how I'm producing the binaries for the different platforms. But another way of doing this is to emulate the architecture that you want to compile to. So we could emulate ARM and compile to ARM. And in Windows, we could emulate 32 bits. I don't know. I'm not even sure that we are going to support Windows 32 bits. In fact, that's very low on my priority list. First, because no one asked, and also because I don't think that many people use Windows 32 bits anymore. And then for Mac OS, so emulating Linux is easy. If you have a computer like I have, which is an Intel 64, you can emulate Linux 64, emulate ARM. You can do that using Docker. It's relatively straightforward, and it's probably something we are going to do anyway here in development during this stream, probably today, because we need to test the stubs anyway. So even if we decide that we will not build the stubs using emulation, we still need emulation to be able to test the stubs. And then there is the issue of macOS. In macOS, there is Intel 64 and ARM, and the streaming machine that I have is ARM, so we could compile there. And this is only relevant for Node 16 and up, because before that there was no precompiled version for macOS ARM with the new M1 processor. There was no build for that, so it doesn't really matter, in fact, because as long as you have this stub and this script, it will detect the right platform and it will do the right thing. But the stub doesn't really matter. From the stub's perspective, it doesn't really matter which architecture you're running your node from, because we are just going to copy the node executable into the package. So coming back to this, there are two different strategies to compiling the stubs. We can cross-compile because Go has this ability, or we can emulate the different platforms we want to target and then run Go in these different platforms and compile. I was leaning on option number one because it seems to be the easiest to work with. I mean, Go is famous for being able to cross-compile, and we are not using anything fancy from Go. We are not using CGO in particular, so we are able to cross-compile. But people have contributed this pull request that I want to read. I didn't have a chance to read this before the stream, but we are going to read this together and figure out what they're doing here. I already know that they are doing emulation, so they're using Docker to emulate the different operating systems in the different architectures, and then calling Go natively in these Docker containers. So one strategy is to just add more options to this list of cross-compilation. Another option is to bite the bullet and do this. And there are advantages and disadvantages to the different options. I mean, this is probably simpler. I mean, the stream is not picking up my screen, but to cross-compile is definitely simpler. It's just a script that you run. There is no Docker involved. But you do need Docker to test this anyway. So, and then there is the issue of some people complain about the reproducibility. So some people complain about something that I think is not exactly related to this, but they make it seem like it is related. The issue is I am putting the compiled stubs in the repository directly. So here under the stubs folder that will show up in your screen after NDI decides to pick it up. I stop complaining about NDI. So there is a stubs directory that is in the Git repository that has all the stubs. They're just binary files. They're around 2 or 3 megabytes each. So I don't think that's too big of an issue, but some people complained that it's bad to have the binaries in the Git repository and it would be better to have them somewhere else, for instance, on GitHub releases. So we may do that. And this pull request may do both things. It may use Docker to not cross-compile, but actually compile using emulation. And it may also publish this using GitHub releases. I don't know, we'll see. So let's read over this. It started in March, so it has been a while since people started working on this pull request. Let's see. This adds a workflow that compiles these stubs and deploys them to a release page. So there you go. It is deploying to a different place. It's not putting the thing in the Git repository directly. Related to number 4, which is the ARM architecture support that we are working on. This runs on both master and tags, which makes sense because you want to build new stubs every time. So it makes sense that it runs on master. And it makes sense that it runs on tags because you would like to publish these tags as GitHub releases and then have the when you install the package, when you say npm install caxa, it would go to the release and get the stub. And at this point, we would need some way to tell which stub to use at installation time, not when you're packaging a project, but when you are installing caxa itself, right? Because you would need to download the right version from GitHub. The GitHub releases would have all the different stubs. You would need to pick the right one. But I guess that's doable. I mean, we could always run some JavaScript during installation and do whatever we end up doing to detect the architecture when you're packaging. We could do that during installation. And it doesn't make sense to have multiple stubs anyway, because in caxa we don't cross-compile. There is no option currently to use a different stub from a different operating system from the one that you are actually using when you are running caxa. There is a whole backstory to why this is the case, and if you're interested, I wrote about this in the README for the project. If the run is, I guess it would also make sense to run this on any branch, because if you're running this on master, it would make sense to run in any branch. Anytime you change something, you may have changed the stub as well, so you would want to create a new one. If the run is on a tag, it also creates a draft release with the stubs uploaded automatically. Okay, that's convenient. A maintainer then has to go to the releases page and finalize the release. See an example release here. Okay. I adapted the workflow from Dungeon Revealer. Okay, what is Dungeon Revealer? I'm always interested in knowing what people are doing with my packages. So they may be using my package, but I don't know. It doesn't appear anywhere here. It's a web app. And it seems like it's a web app that people will want to self-host. Yeah, it's an open source self-hosted app. So that's an excellent use case for caxa, because that's why I developed caxa in the first place. Awesome. I wasn't sure how you would want to package the stub, so I left it like the previous project. Here is the output of the file on each of the stubs. So the person included Linux, ARM64, ARM7, but not ARM6, and then macOS, but not the M1 processor and Windows. Okay. And then there are some to-dos, but they are all done. But let's see. Cross-compile binaries. So the person is not emulating using Docker. They are cross-compiling using the ability that Go has to cross-compile. Add tests for the stubs. That's interesting. What do they mean by that? I don't know. Because I already have in the current version of caxa, yeah, I have a matrix, so I'm already testing on macOS, Windows, and Linux. And I'm testing on Node versions 14 and 15. So I am already testing all the stubs there are in the current version of the project. But maybe the person means we are adding tests to the new stubs, like the Linux ARM stubs. And MD5 sends of the binaries for build transparency. So that's another thing that I don't get. Many people say, oh, the problem with putting the stubs in the repository is that there is no transparency to how you build this. Well, I think that if you're using a binary that has been compiled by someone else, you have to trust that person, because I could go into the GitHub release and change the binary that was produced by the GitHub action. So if you really don't trust me, you should just inspect the Go source and compile it yourself. But at that point, you're now trusting the Go compiler to do the right thing. What if the Go compiler that you are using has been compiled and has been modified to include some malware? You cannot really trust the Go compiler, so you have to compile the Go compiler yourself. Then you have to read the whole Go source code and compile before you compile it. But Go is written in Go, so you need a Go compiler to compile the Go compiler. At that point, it becomes this circular problem. You have to put your trust somewhere. And I'm not saying that you should trust me. I'm just saying that this is not a solvable problem with technology. It's a political problem. It's a policy problem. There is an article called Reflections on Trusting Trust that is about this. What do you do when you cannot really trust your compiler? And that's something that is interesting. How can you even trust that a binary was produced from a certain code base? I believe there are ways for you to sign something saying that this was built from this code base, and there would be some way to verify the proof of this connection between source and binary. But I don't know how that would play out, and I know for sure that this is beyond the scope of caxa. Okay, that was a side rant on trusting trust. But the idea of having MD5 seems like a good idea, because if you're not shipping this with the repository, you may not be shipping this along with the npm package. As I said, you could have the npm package when installed, go to GitHub and get the release. And at that point, it would be nice to have MD5 or some sort of checksum to make sure that what you're downloading from GitHub really is what you expected. But I don't know. And then convert actions, upload release asset to, okay, whatever. Just a different way of uploading release assets. And in fact, in some of my other projects, I am using upload release asset with this one. I have no idea why this one would be preferable. Okay. So someone else says, not much of my business, and most likely I'm missing something, but why is this pull request necessary? The way I see it, it's 172 lines of build stubs versus the following 6 lines executed on my Intel machine, NOS, without the need for Docker or KeyEmu. Just for context, I said that you can emulate other architectures like ARM using Docker, but you can also emulate using KeyEmu, which in fact, the way it works is Docker, if you want to emulate a different architecture, will use KeyEmu under the hood. So by the end of the day, you are using this, which is an emulator. In any case, these are the 6 lines, and that is also my initial reaction. Why would you want to have Docker and this whole infrastructure and GitHub releases, and then you have to figure out something to download when you're installing the package? If you could just ship everything along with the repository. In any case, let's see. Oh, and these lines are kind of cool. I'm collecting all the lines that I like, and I'm putting them in various places. I'm collecting these as well. And it's fun about what's fun about this stream is that I said we would let's write some code together. And what I'm doing is just mostly reading, but Caxa, I will go on another side story here. Caxa is a very simple project based on a very simple idea. There isn't much code in Caxa. It's like 100 lines of code or something. But it took a lot of time to write those 100 lines of code. I had to think about it for a long time. I had to do a lot of research. That's usually how I end up writing my code. I do a lot of research, a lot of background story, a lot of finding things here and there. I tested a dozen different solutions for packaging Node.js applications. And then eventually I landed on this very simple package that is 100 lines of code. That is Caxa, the one I developed. But that's usually how it goes when I'm doing more of these serious things. It's a lot of thinking, a lot of reading, and then just a little bit of coding. I still think that it counts as coding because, I mean, that's what writing code is all about, figuring what you want to write. Okay, so let's see. Okay, I see the value in making sure that the stub binaries are up to date in relation to the Go source. And the fact that a binary commit from some random contributor cannot be easily reviewed for including a Bitcoin miner. Yeah, that's something that I would never do. I would never just accept a pull request that includes a compiled binary. I would always compile the binary myself. But it's such an easy thing to do. I just run an npm script. And I have to set up Go, but that's not too hard. I think we'll do that in this stream. But then maybe the workflow could be just Ubuntu on Intel running the 6 lines above. Caixa's README makes a point about not supporting cross-compilation, but I understand that's about native Node.js modules of the end user's application, not Caixa's own stubs. After all, the binary stubs for all platforms are even committed to the GitHub repo. Yeah, exactly. I don't really believe in cross-compilation because of all the issues with native dependencies and whatnot, but the goal... Can you hear the baby? So Go has this community that really cares about writing everything in Go instead of using C Go or something, which is definitely not the ethos of the Node.js community. We embrace native extensions, but Go has all these libraries written in Go so that you don't need C Go and that you are able to cross-compile, which is one of the advantages of using Go. So I thought, yeah, I don't really believe in cross-compilation except in this very exceptional case that I'm using cross-compilation to bootstrap the process of producing binaries. But then Caxa itself does not cross-compile. Okay, so the main point of this pull request is to put stub compilation in the CD pipeline. I was avoiding cross-compilation because the repo owners seem not to be a fan of this, as you pointed out. Yeah, I'm not a fan of cross-compilation, and this is the paragraph I wrote in the README to explain why I don't believe in cross-compilation for Caxa in particular. Using our cross-compilation script would certainly simplify it would simplify the workflow, but puts all your trust in the Go cross compiler, which is an issue. I read somewhere in one of these conversations that there were some bugs in the cross compiler. We could test and see if the bugs come up, and if they do, then we do something else. But initially, it seems like cross compilation is okay. Is this better? Do I look less yellow now? Can I go even further with the color balance here? Okay, this seems better. This seems a lot more blue. Using our cross compilation would certainly simplify the workflow, but puts all your trust in the Go cross compiler. Emulation at compilation is more complex, but also ensures the build environment is closest to actual hardware, which I do appreciate. Pick or poison, I guess. This is what I'm aiming to change, the fact that the binary stubs are committed. Committed binaries to it's a bit sketchy. It isn't perfect, but it's not bad. And then this is me making the argument I guess I just made right now. And now the person that initially commented on how simple things could be coming back and saying, playing devil's advocate here, see pros and cons. There may be a room for simplification, as I pointed out in my previous comment, but a CI workflow can help you save time, because I do have several open source projects to maintain. When an external contributor submits a pull request that modifies the stub, then I don't need to compile everything by hand, but I will anyway, I think. I think it's better I always want to compile the thing from scratch and distribute from the thing that I compiled. Or maybe a CI workflow would be acceptable. If a contributor's commit includes the stubs and the contributor is not someone you know and trust, you could not possibly simply approve or merge the pull request with the binary stubs, which is not a big issue because I don't think that caxa will move that fast. You might find yourself awkwardly asking the contributor to delete the binary stubs from the pull request. That's not something I would do. I would just fix it myself, as you cannot trust them and you need to generate them yourself. I would just cherry pick the changes, I suppose, but in any case. But if GitHub's workflow takes care of producing the binaries, the contributor's commit would include only the changes to the stub, and you could simply merge the pull request and go back to the other open source projects. True. Automated testing of the stubs by executing them in GitHub's sandboxed and virtualized environments. While it's easy to cross-compile the stubs on every OS and CPU, executing and testing them on a non-native operating system may not be as easy. Currently, however, this repo does not have this kind of test. It actually does, because currently the only stubs that we have are Windows, macOS, and Linux, which we are testing in our GitHub actions. I showed this a couple of minutes ago. The stubs are small, around 3 megabytes. Yeah, but we'll have several of them, and they are going to keep being committed again and again. So yes, there is Windows 64, Mac Intel, Mac ARM, Linux Intel, and then ARM 6, 7, and 8. This will show in the unpackaged sized entry at blah. True, so anyone who installs caxa as it stands will download all the stubs. They will not download all the stubs that have ever existed, because in npm you don't download the whole Git history, you only download the release, but in a release there will be the stubs for every version, and that will be 21 megabytes. But we are talking about the Node.js community here. We have hundreds of megabytes of dependencies. We have gigabytes of dependencies. Right? Do we care about this that much? And it will also show in the Git repo. You're not seeing. I changed the screen back to the comment. I'm reading the comment. Yeah, it picked up now. And the Git repo will keep the history. One line changes to the stub could mean another 21 megabytes committed. Soon enough, Git clone will be downloading hundreds of megabytes of old stubs that no one cares about. Good point. Yes, that is the case. Even so, transparency could be increased by adopting a GitHub workflow. You might be able to add a feature bullet point to the README that says binary stubs reliably generated with GitHub workflows with a link to build stubs. That's a false sense of truth, in my opinion. You're saying that the builds are generated by GitHub workflows, and that's true. And it gives you a false sense that it makes anything more secure or more trustworthy, but it doesn't, because I could always go into a GitHub release and change the asset in there. Using your cross-compilation script would certainly simplify the workflow, blah, blah, blah. I'd say that it's fine until there is an evidence to the contrary. Add complexity only when justified. I very much agree. Yeah, I'm still leaning towards let's use cross-compilation on the Go side. Okay, so let's say Git was designed to handle version control of file texts, of text files. That's not true. I corrected the person below, but that's something you may not know, you who are watching me right now. It seems like Git stores diffs of files, but it doesn't. It stores the whole file. It shows diffs of files because that's easier for us as humans to look at. Internally, Git stores all the versions of all the files. And then it tries to compress things so that the .git directory is not huge, or not as huge as it would be if there were no compression. That can lead to repo sizes growing very quickly if the binary file changes frequently. Yeah, if the binaries change frequently, the Git repo will balloon in size. At the very least, you should use a tool specifically for storing binary blobs in a Git repo, such as Linux, it's not LFS, it's large file storage. Yes, it is LFS. So large file storage. I will never use large file storage for this. If necessary, we'll go to the GitHub releases approach. The workflow at least shows the whole process of generating the binaries. Anyone would be able to see the exact commit of the source and the whole build process. Well, there is already a script in the package.json file. So the process of generating the binaries is already transparent and anyone can run very easily. I would say even easier than downloading and installing Docker and whatnot. Anyone would be able to see the exact commit of the source and the whole build process. Yeah, you could see the logs in the GitHub Actions, which I guess could be nice. I can include MD5 sums in the build process as well to mitigate administrator abuse. Okay, so you would see the logs in the GitHub Actions, and the logs would have an MD5, and the MD5 could be checked. I would probably not use MD5 for this. I would probably use some other kind of checksum like SHA-260. 256, yes, it's SHA-256. But in any case, I would use some checksum. And then the thing is, you cannot fake a GitHub Actions log because it's attached to the source. So now you're putting your trust on GitHub, but you're still trusting humans and companies, I guess. And the Go compiler, and a bunch of things, the operating system. Of course, you can never have 100% trust binaries from the internet, but you can take steps to help people. Okay, I buy it. I think the current repo structure of caxa makes sense given its current scope. However, if it grows in popularity, a lot of people are excited by it. Oh, awesome. I think you need to rethink that structure. Yeah, for sure. As things grow, they change. I'm never saying that a simple architecture will be the best for every situation. It will be the best for the specific situation I'm talking about. Having a robust workflow in place could save you time and headache in the future. That's just the thing. Premature optimization is the source of all evil. Is that the phrase? Yeah, we have to think very carefully if we want to do this or not, because It's always easier to add these new architectures and abstractions than to remove them later if we decide that they are not ideal. Okay, so the person is saying that they will add a simple smoke test for the stubs, and I guess I understand now that bullet point in the beginning. It is a matter of running our test suite on the different architectures using Docker probably. That's totally a fair point. I think adding tests to the stubs to the workflow would justify the complexity though. Yeah, if we could test the stubs in Docker using GitHub Actions, that could be a good selling point. Okay, a workflow shows the user the build log that produced the binary file. The stubs command in package.json just tells the user what commands are needed to build the stubs themselves. Fair. Using a metaphor, the workflow is like being in the kitchen to witness every part of the meal being made and delivered, while the stub command plus binaries in the repo is like being given the recipe for a prepackaged meal. You could certainly make it yourself, but there is still a gap in the chain of custody. Okay. As long as I don't find a way to fake the logs, right? Here is the build log I'm talking about. You can trace the process from source all the way to build artifact. Okay. I'm getting more and more convinced the more I read this. These people are making a fantastic job of investigating all the approaches and discussing the trade-offs. I am delighted by this pull request and all the conversations we are having in the caxa repository. Super glad to be a part of this. As far as the binary distribution goes, I think removing them from the repo is a net positive. The caxa dependency would have a smaller size, and all that needs to happen is that caxa fetches the appropriate binary after identifying the system it's running on. Exactly. GitHub releases provides direct links to the binaries. True. Where version, okay, awesome. So you're making the job a lot easier. I've added some new features to this that may persuade you of its usefulness. You're awesome. Binary testing. There are simple tests of all the binaries. Let's look at what they have under this link. What is this? So there is a matrix of testing, Ubuntu, macOS, and Windows, Ubuntu, macOS, and Windows. But come on, I already had that. We had a matrix. But are you testing ARM? Test ARM. And then Linux ARM, Linux ARM, and Linux. Awesome, awesome, awesome. Binary checksums. File checksums are performed during the build. Let's see what they have under this link. Okay, so it's producing checksums of all the stubs and also the source for that matter. So file checksums are performed during the build and are deployed with the binaries. Users can verify that the file they download is the same as was built by actions. Yeah, that we can trust. We can trust that whatever they have is what was produced by us. If you trust us, then you trust the binaries. That's the relationship. Simplified release creation. There is a simplified action to create the GitHub release page and upload the files to it. It's much easier to understand now. Awesome. Some outdated comments. The emulated binaries aren't working as expected for ARM on the Raspberry Pi. I will convert this to cross-compiling all the binaries and possibly testing them with emulation. I changed this to cross-compile all the binaries and then test them natively on emulated in the case of ARM architecture. So that's interesting. So what they are saying is that the binaries that were generated using Docker and emulating the architecture are not working while cross-compiling is working. I thought it would be the other way around. I would put more trust in the emulation layer than in the cross-compilation layer. But, you know, it's always faking something, right? An emulator is faking an architecture, a cross-compiler is faking an architecture, so these things sometimes go wrong. So someone says on the chat, Lauren, hi Lauren, if you embed the SHA-256 of the file in the published npm package, the installed package can verify that the GitHub release was not changed. Exactly, yeah. So if we produce this MD5 or if we produce this checksums, then we ship that along with the npm package, and then you can trust that whatever we put in the GitHub releases is whatever you end up using. So there will be no way to interfere in this download. If there is a man-in-the-middle attack that is trying to provide you a fake stub, you will detect that. The problem really here is, if you can be a man in the middle, faking the stub coming from GitHub, couldn't you also fake the npm package coming from npm? And if you do it, then you could change the checksum on the npm package, and you could change the stub as well. Unless there is some kind of notion of trust when downloading packages from npm. I don't know about that. The Somnus50, hi, says, it was actually a problem with the emulated compilation command. See the table? Okay. I remember reading something about this over here. There is a table here somewhere. Okay, so emulation works every time. So there is a table here, super helpful, by the same person, MaxB2. So if you cross-compile stuff using the Go cross-compiler, it sometimes doesn't work, but emulation seems to always work. That's what I would expect. If you emulate, then you are faking on a lower level. You are faking the processor architecture. And then the Go compiler running on top of it will do the usual Go compilation thing, which should work. But if you're cross-compiling, then the agent faking the architecture is the Go compiler. And I put less trust in the Go compiler to be able to cross-compile stuff than I trust QEMU, quick emulation. I think that's what the name stands for. So that's I put more trust in quick emulation than I put trust in the Go cross compiler. I changed this to cross compile all the binaries and then test them natively on emulated in case of ARM architecture. I just watched your stream. Hello. It was good to see your vision of where caxa should be heading. Thank you for having. I'm thankful to you for all the work and for having you here on the stream. As far as the method of compilation goes, this pull request is currently cross-compiling the stubs and then testing them in native or emulated environments. If you would prefer they be compiled in a native emulated environment, I can easily revert back to that. I would say it's a judgment call up to you, but which method should be used. I hope this pull request makes compiling and distributing the stubs off your plate. Yes, it makes everything a lot easier. There's still some work to do to find which stub to use when installing the package, probably, or when building a binary with caxa. So we'll have to pick the right stub at some point, but at least building the stubs is easier. So it seems like from this table that cross-compilation sometimes fails, but cross-compilation is what is being used here. At least that's what the person said. So definitely cross-compilation is what's happening here. And we already need emulation to test. So I'm more leaning towards emulation, right? Because emulation would not cause this problem. Emulation would be a success. So I think it's time for me to make the call. And I think I will go with emulation to build the binaries. And I think I am sold on the idea of building things with GitHub Actions and testing everything with GitHub Actions. So we would emulate the operating systems and different architectures to build this stub and then to test. So we would just run our test suite. What are they doing in terms of testing on this pull request? Test ARM, checkout node, download artifact, setup key UMU, test binary. Would it be possible to run our tests instead of doing this bespoke testing? It's a simple smoke test, yes, but it would be nice to run our test suite. We can think about this. The Somnus50 says on the chat specifically, it's that the cross-compiled ARM7 binary doesn't work on an ARM6 machine. Oh. But why would why would an ARM7 binary work on an ARM6 machine? It shouldn't, right? Did I even read something wrong here? Oh. That's weird, because I am assuming from reading this comment that a Raspberry Pi 1 is ARM6. And what you're saying is that if I compile for ARM7 using an emulator, it works on ARM6, but if you cross-compile, it doesn't work. I don't really care about that use case because you would compile to the architecture that you're actually using, not depend on some sort of... I assume there is some layer of compatibility between ARM6 and ARM7 for the ARM7 executable to even work. That's weird. I'm thinking about kind of an emulation layer the way that you have in the new Macs with the M1 processor, where you can emulate an Intel processor, the Rosetta 2 thing that came with Big Sur, the new macOS version. Okay, so cross-compilation is not completely off the table, but I'm kind of sold on the idea of using emulation to build stuff. And I'm kind of sold on this idea. And I will like to do this in the GitHub Actions for the transparency thing. Oh, so this Somnus50 is also Max B2? Are you the same person? Awesome. Thanks for being here. So they say exactly. I was just showing how weird the situation is. Yeah, the situation is super weird. If you compile something to ARM7 and it works on ARM6, I would be spooked, because I don't expect the Raspberry Pi to have the kind of emulation layer that macOS has, because it doesn't need one, I don't think, and because it's expensive to put these emulation layers in the way, right? It's supposedly faster to run a Mac program compiled for ARM when you have a Mac with a M1 processor. It's supposedly faster to run an M1 program than to run with Rosetta using the compatibility layer. So yes, the Somnus50 is Max B2. All right, Max B2, you are awesome. I am definitely convinced by your argument, and we will do things the way that you suggest. And they also say Go only has an ARM6 version, which was used to build both emulated binaries. Oh. So you're saying that I cannot cross-compile using Go, and I cannot cross-compile to use ARM7. I think that's incorrect. I remember seeing somewhere a command that included Go ARM, and then you could say if you wanted ARM6 or 7. So Go was supposed to compile to ARM7 just fine with cross-compilation. In any case, Felipe Castillo, that's another person that is here somewhere in these threads. Yes, hello, it's nice to have you here. Just wanted to say thank you for developing caxa. It's going to make my life so much easier once ARM is done. Yeah, it will be done by the end of this week for sure. Lauren says, also Node is only available for ARM6, 7 and 8 precompiled. Yeah, Lauren, that's a good point. I went to the Node download page to check this, and yes, there are only versions that are precompiled for ARM7 and ARM8. There is no ARM6, but that's the beauty of the architecture we are using for caxa, the beauty of the simplicity of the way caxa is built. I don't have to care about this, because as long as we have a stub for the architecture, to even be able to run caxa in the first place, you need Node.js. And whatever Node.js version you're using to run caxa, that's the Node.js that I put in your compiled binary in the end of the day, the thing that you ship with caxa. So if you have some way of installing Node, and I assume that these people have solved this problem already, maybe by not using one of the official executables, but downloading it from somewhere else or compiling themselves, as long as you have that Node executable, we will be able to use it in caxa. And it doesn't matter if it's a new version of Node, an old version of Node, if it is ARM or Intel, we don't really care. And then MaxB2 says, go to the Go download page. Okay, I can go to the Go download page. And I remember reading a long thread about why there is no Node 6 Docker image. Do you mean Node 6 as Node version 6? That's very old. Or Node 16 maybe. Maybe Node 16 for ARM. Okay, Node for ARM6 Docker image. Oh, so there is no Node for no Docker image for ARM6? Is that the case? Let's see. Let's go again to this beautiful GitHub Actions configuration, and then there is Linux ARM6. So yeah, there is a Docker image for Linux ARM6. That's good. Okay, there is a long thread about why there is no Node for ARM6. Why in this download page there is no ARM6 option. And there may be reasons for this, but it may be reasons that people don't care about and they compiled Node.js for ARM6 anyway, or that's just the beauty of this. I don't really have to understand this. I don't really have to care. I will just provide the binary, the stub, I mean. I will provide the stub, and I will detect the right architecture, and I will use the right stub, and it's the caxa user's problem to find a way to get a node executable for their architecture. So I'm going to bite the bullet. We are going to use Docker both in the build of the stubs, but also for testing the stubs. And I need to have Docker installed here on my machine to test all this, to experiment with all this. I mean, having a GitHub action is awesome, and we will have that. I am convinced, but I still need to have this on my machine to test and to play with this. So for the rest of this stream, what we are going to do is to install Docker, and I have not installed or configured Docker on this machine, especially not for running ARM images, which is a different story. So we will install, configure Docker, and go. If you are here watching this, I assume that you already know how to install and configure Node.js, and I already have this on this machine, so I'm not bothering doing that, but I will have to set everything up, and I decided to do this on stream, so I'm not hiding too much from you. And if you're interested in contributing to Caxa, then you can follow the steps and learn how things work. So I'll brew install Docker and go. And it's unfortunate that my screen isn't showing up as fast as it should, because now I will move faster here on the screen. And I have already tested this before on a different installation of macOS. Oh, so it's treating Docker as a formula. For a cask, use this. I will probably want to use the cask. Let's see, treating Docker as a formula. For the cask, use that. Downloading this. I have no idea what this is, but I suppose it's probably gonna be like only the command line version of Docker, especially because it installed so fast. And now it's installing Go. So let's briefly talk about what you need to do to set up Go. You have to install the Go compiler, and that's it. I'm not using any cgo or anything, so there is no extra thing you have to configure, like no Go path, no Go modules, no nothing. I know very little about Go. I am using Go here as a means to an end. So let's see, I don't think I have Docker here. Yeah, it's not there, but I suppose I have Docker on the command line. Yeah, so just by saying brew install Docker, I got only the command line version. Do I even have Docker Compose? Not that we need it for this project, but it would be nice to know. Yeah, it doesn't even have Docker Compose. So brew uninstall Docker and brew install cask Docker. Why do I want the desktop version? Because as far as I can tell, only the desktop version has the architecture emulation built in. Now it's taking a bit longer to download everything. Yeah, and I suppose that here on this big GitHub Actions configuration, you had to somehow say that you want to emulate the different architectures. Yeah, so there is some QEMU setup situation going on here, because by default only the desktop version of Docker has the architecture emulation built in. But we already have Go. We have installed Go on the previous step, and for developing with Go in Visual Studio Code, you have to not only have Go. That's enough for us to compile a stub, but it's not enough for us to work with Go code. If I open a Go file, it should complain that I don't have lots of packages necessary to do things like formatting and linting and everything that the Visual Studio Code extension for Go does. So I'm going to try to compile this stub real quick. So let's go to stubs, and you know what? What I can do is just say npm run stubs. Okay. I'll have to npm install first, but let me double check that I have not run npm install before. Yeah, there is no node modules here. So npm install and npm run stubs. And this should prove that the Go compiler has been installed successfully. And meanwhile, I am installing Docker. And while all that is happening, we are going to be multitasking here. We can start to think about how we are going to download the correct binary when you install Caxa. So we are not shipping the binaries with the npm package anymore. So we will have here probably a post install script that will download things from GitHub Actions, and it will download from here. So for now, I'll just say something like wget. This is really just a comment, sort of, so that I remember what we will need to do. So we will need to download this stub, and we need to put it somewhere. And later in the script, when we are calling caxa and building the binary, the stub will always be the same and in the right place. So we will not have to detect the architecture the way that we are doing. Where is it? Right here. We will not have to detect the architecture because the stub will always be in the same place. Which is sort of cool. But we will have to write equivalent code to download the right version. So let's see how the Docker installation is doing. It's still installing. And let's see how the npm thing is doing here. Okay, so there is an error here in the npm install. And I remember running into this error before, and I think it's now a good time to fix this because it should be easy. The problem is that we have here in the prepare script, we are compiling TypeScript. By the way, I didn't mention this before, but caxa is written in TypeScript. So we are calling the TypeScript compiler. And I have this in the prepare script so that if you install caxa as npm install liafac caxa, this will get the package from GitHub, not from npm. And then it will download everything and it will run the TypeScript compiler. Yeah, I think that's how it's going to work. In any case, when I have this, and also prepare, I guess that's the most important use of prepare, it runs right before npm publish. And it produces the JavaScript files that you actually run here under lib. Now, the issue that I'm running into right here is that when I say npm install, it runs prepare, and prepare runs TypeScript, but since I last ran this prepare thing, I included some examples here that are used in the tests, and I believe in one of these there is some TypeScript, and it complains, yes, there is some TypeScript over here. So in the examples, web application, I wrote this one in TypeScript. So there is a TypeScript source that is in the examples folder, not in the source folder, and then TypeScript is complaining about this. I don't know exactly how to fix this though. And when you run TSC, does it try to compile the examples? It does. So what I want is not only to compile only the things in the source, but I want to have TypeScript only look at these sources. I don't want TypeScript looking at all the other files in the examples directory. We'll have to figure this out. I don't know. But in any case, the npm install ran successfully. The prepare that ran right after it failed. I'll delete the lib directory right now. But now we can run npm run stubs. And this will compile the stubs using Go and prove that we installed Go successfully. It's as easy as saying npm as easy as saying brew install Go. And it ran successfully because no error messages were shown. And then in the stubs directory, we should have new stubs. And yes, they are new stubs. They show up here as different files on Git. Meanwhile, Docker has successfully installed. So now we can run Docker. And Lauren says, include or exclude option in TS config for narrowing down the files. Thank you. So I'll quickly search for TypeScript lang, and then there is this awesome link for all the configs. Docker desktop needs privileged access to install its networking. Okay. Okay, I need to type in my password real quick. So I'll change cameras. Coming back. So include. Oh, so there was another thing here. Root files. Files specify an allow list of files to include in the program. No, that's not what I want. Include specifies an array of file names and patterns to include in the program. These file names are resolved relative to the directory containing the TS config. So if I do, let's go to the config file, and then I will include only source, and I don't have a separate directory for the tests. The tests live in the source directory, so I don't need this part. So with that, I can npm run prepare or whatever, and this will succeed now. Yeah, it's running TSC. And things are getting slow because I am using as my development machine, my old machine, and now I'm running Docker, I am streaming, I'm doing all these things on the machine. Unknown compiler option include. What? I mean, I copied this from the configuration. Also, maybe it's not under compiler options, it's literally just under at the top level. Maybe that's it. Awesome. And it produced a lib directory with the examples folder is still in there, but it may be a leftover. So let's run around the block again. A lib directory with only our sources in there. And let's double check that we have not changed any of the paths. So when I here in the package JSON, I have lib index.js, and I will end up with lib index.js. So that fixed the issue. Awesome. Thank you. Lauren says, move it out of the compiler options object. Yeah, I was able to to find that one. And there is a bit of a lag when I am reading things and saying things. I had this configuration where I would try to optimize for no dropped frames in the stream, which means that there is a bit of a lag because there is a buffer. It is around like 5 seconds. And in the next stream, I may try to use a different setting that it may be faster, it may be even higher quality, but I don't know. I don't know if my computer can handle encoding and buffering, and if my network will handle everything fine, but I think it will. We'll see. Maybe in the next stream, I will be quicker reading the comments. So we already have something here. We fixed something. That's awesome. So ts config, whatever. Don't really care about commit messages at this point in the project. And we have installed Go. We have set Go up. We did not install all the dependencies needed to work with Go on the command line. So if to work with Go on Visual Studio Code. So for instance, if I change the formatting and then I try to format, there are no formatters for Go install. Well, there is Go. It's installed right here. So I guess what I need to do is to close Visual Studio Code, reopen Visual Studio Code, and then it will prompt me to install the Go dependencies for the Visual Studio Code extension for Go. Install all. And we'll test this later. After everything here has been installed, we'll come here to the project, to this file, and try to change something and see if the Go formatter is kicking in. Go outline is not available. Install all. Didn't I just tell you to install all? And there is a Go update available for Visual Studio Code. A newer version of Go is available. Whatever. Docker desktop. Get started with Docker in a few easy steps. Skip tutorial. And then let's make sure that Docker is installed and running correctly. I am going to open a new terminal. Paste this in there. And it will download the getting started image. And I'm not really interested in Docker only. I'm interested in the... Okay, so it ran and then I need to go somewhere, probably like localhost 8080. Or maybe not localhost, because I don't know how the port forwarding works in this image in particular. You know what? Never mind. I don't care about the hello world image anyway, so... Oh, it's running in port 80. So I guess I can try localhost 80 real quick. There you go. So yeah, Docker installed successfully. But I'm not interested in Docker for Docker's sake. I am interested in the ARM emulation available here. So can I stop this? And then there are these images by Belena that emulate Raspberry Pis. It's Balena. Okay, Balena lib. So let's try emulating a Raspberry Pi real quick. So I need to say Docker. It's pretty much like the previous command, Docker run. I don't want it to be detached. I want it to be interactive. And I don't need port forwarding, and I don't need that image name. So I guess this will do. Oh, I didn't tell what command to run. We'll see what this does. By default, it will have a command and it will just run whatever command. Okay, so it didn't do anything. So I'll try bin bash. Okay, I am in the Docker image. Let's run uname all. And this is running Linux ARM 6. Awesome. So I have configured my machine to work with Go, to work with Docker, to emulate an ARM processor in my Intel processor. So I'm able to emulate everything and I'm able to build the stubs and test everything. So my development setup is complete. I have installed the node packages as well. And I think we will be good to go. I think we have everything we need to start working on this for real. So let's see. The Somnus 50 says use build for the Docker image to get more build software. Okay. Like what? What kind of build software? You mean like a C compiler or something? Maybe it comes with a Go compiler already. Oh, that's a lot bigger. So it is like 100 megabytes. So I'm betting that this will come with a Go compiler. C compiler and build essentials. Okay, so yeah, build essentials is a C compiler, is make, and of course the linker that kind of comes with the C compiler, more than we need probably. But if it comes with Go, no, it doesn't come with Go, but it does come with Make. It does come with GCC. It does come with G++. It does come with LD. Okay, and just to make sure I understand what's going on here, if I was using the other image, it would say GCC not found, make not found. Okay. We probably can make do without build, because we just need a Go compiler. We also need Node if we want to test. So maybe the build one comes with Node. This one doesn't come with Node, I suppose. And then build, does it come with Node? Node, no. So I don't really see an advantage to using build. I mean, it's not like we are actually building a Docker image that we want to ship. The Docker image is just a means to an end. Whatever. Either image, I guess, will work for us. And I created a bunch of these because I forgot to say --rm when doing this. Okay, so we set everything up. We really discussed what we want to do. There are two things we need to do, and we are going to do them in this order. We need to compile the stubs, and we will do that using GitHub Actions. We will have the checksum and everything. And because we need the emulation to test these stubs, we will have emulation to build the stubs as well. I think it's a more principled approach. There are some things to think about in this step, which is building the stubs. We have to think about how we are going to do that in development. Well, I guess we can do the Docker thing I just did. So we will do that for building, for testing. We will also, and then there is the second step, which is to change the JavaScript portion of caxa to use the correct stubs when building or when installing, really. We'll do these two things in this order. We'll start with building the stubs, and then we will move on to the JavaScript portion. And for building the stubs, we'll do the GitHub Actions. We will use emulation. Yeah, I think it will be fine. So we are going to wrap it up. Felipe Castillo says, I haven't tried this, but maybe this image might be useful. Oh, okay, so there is a Raspberry Pi Golang. You can also use the build postfix for that image. Okay, so our requirements are in the Docker image, we will need, at least that's my idea. Let's see if you all agree with this. My idea is that we will have a Docker image that has both the Go compiler for building the stubs as well as a Node executable for the tests. And what we do when testing on Linux and macOS and Windows, we will do exactly the same for ARM. We'll just use a Docker image instead of the native GitHub Actions runners. But let's give this a try real quick. So there is this balenalib, Raspberry Pi, Golang, build, whatever. And if it comes with Golang, that's half of the battle. Then we will also need to install Node. Oh, but there is a wrinkle. Remember how Node.js is not easily available on ARM6? We'll have to hack around that. And that may be the reason why Max B2 had that simple smoke test, because that one doesn't require Node in the Docker image. It's difficult to find an image with both of these for all architectures. Yeah, I think we'll have to do some installation ourselves. You can actually build, Lauren says, you can actually use a Docker file describing the build and run flow. Yeah, you can always install Node and Go at runtime. I think that's what we'll have to do. I don't think there is a pre-compiled image with both, but we can check. So now we are here in this Raspberry Pi Golang build image, and it does have a Go directory, so there is probably the Go compiler there. And that's not how you ask the version of Go, it's like this. So yes, it's not the latest, but it's there, and Node.js will not be there. But we can apt install Node, probably. Or we can just wget Node from the Node.js website, and that will be easy. Exactly, then you can copy the binary out of the container. Yeah, we will build the stub in the container, and we will copy the stub out of the container. We will not bother copying the Go compiler or the Node executable out of the container, but we will need a container with both. The stubs require Go 1.16. Really? I don't know. I don't know which feature from Go 1.16 I used, but I trust you. Use nvm to install Node, that way you can test for any version of Node. Yeah, we do want to test for at least 14, 15, and 16. So is it easy for me to apt install nvm? I bet that that's not a thing. Yeah, but it's easy to install nvm. Oh no, I ran this on my machine, not on the Docker machine. This will mess things up. Oh no, I'll have to fix this later because I have already installed nvm on my machine. Oh boy. Okay, whatever. You'll have to do something like this in the build process in GitHub Actions. Pending, blah, blah, blah. So now nvm is already available? No. But what if I source my .bashrc? Is nvm available now? Yes, it is. So I can nvm install, for instance, the latest. Compiling on ARM6 takes a long time, as far as I can tell, with emulation. What am I running here? I know that I'm running this image that has Go, but I'm no longer sure which version of Raspberry Pi it's running, so I don't know which architecture I'm on. Oh, it's running ARM6. So it seems like there is an ARM6 build. It's just not on the downloads page, but it's there. Oh. Oh, no, it failed. It failed. There is nothing there. So it will take forever because it will try to compile here. It's downloading the source. It is building. Oh no, I don't want to do that. That will take for freaking ever to finish because I am on ARM6. Yeah, compiling Node from scratch is not the way to do this. If we need to just build the stubs and not really run the tests on ARM6, I am fine with that. We'll not test in ARM6. We'll just test in ARM7 and 8 because we can have precompiled binaries for those. I don't want to compile Node from scratch. It takes forever. Okay. I will read the rest of the chat and I'll wrap it up. I need to go back to my family. The baby was crying before. Use nvm to install Node. That seems like a good idea. Compiling on ARM6 takes a long time with emulation. As Lauren said, ARM6 is going to be the hardest. Probably leave it for the end. Probably not testing on ARM6. The stubs don't care what version of Node you're using. If Node is only going to be used to run a test script, it's kind of overkill. Exactly. I'm not in the business of compiling Node for ARM6. We may find an executable somewhere and we can just download it from somewhere that is not the official build. we may look into that, but whatever. There is also Belena Raspberry Pi 3 Golang and Raspberry Pi 4 64 Golang. Awesome. So if we use those base images, we only have to look at how to install Node, and we know how to do that with NVM. So I think all the pieces of the puzzle are in place here. And yeah, let's wrap this up. So today we set up a development environment using Docker for emulating ARM, and we set up Go on my machine, which was very easy. We looked at how we want to build the stubs. I was convinced to switch the approach to actually use GitHub Actions and have a more automated way of building. And next time we are I guess we are going to just look over the script here on this pull request and make the necessary changes so that it is doing the emulation and then compiling the stubs in the emulator, and then maybe running the tests with Node, so installing NVM, installing the correct Node versions and running the tests, and then putting the stubs in the GitHub release. Well, we need to upload the assets somewhere if it's not a tag, if we are not releasing. So upload artifact is for a build artifact, right? And then it's a release asset. Yes, so it's build artifacts and release assets. So yeah, okay. So we are going to configure, we are going to read over this workflow, this GitHub Actions configuration, and we will turn on emulation, build the stubs, upload the stubs, run some tests on the platforms on which that is easy to do, installing NVM and installing the correct versions of Node that we want to test on. And then we will have built the stubs. Then later we will have to figure out the situation about how to install Node, how to install the correct stub when you are installing the package. The Somnus50 says build artifacts will be attached to any run. Yes, build artifacts are attached to the run, and release assets are attached to the releases that we will create when we have text. I will update the pull request this afternoon. Oh, thank you. Thank you. Thank you all for coming. Thank you all for watching. Thanks for being with me. If you want to support my work, subscribe to the channel. Support me on Patreon and PayPal, or just show up for the streams. That's always fun. I'll be back here tomorrow at the same time, which is 6:30 on my time zone. It's 5:30 UTC. In the US, it's like in the morning or beginning of the afternoon. I don't know. And yeah, I see you all tomorrow. Thanks for coming. Bye.